Welcome back to class today. I want to believe that if you have not subscribed to our YouTube channel, you should do so that you can get updates on our video. This is chemistry class and I will be your chemistry instructor. And today we are looking at a very important topic in chemistry, which actually forms the basis of our knowledge in relating with chemicals. Today we are looking at the topic acids, bases, and salts. This is a guide for O-level students, A-level students, and in this module you are going to learn a lot. So it's very important that you sit back to watch the video to the end. So let's give it a go. Today you're going to, at the end of this lesson, be able to understand the concept of acid, base, and salt. You should be able to define acid, give conspicuous example. You should be able to differentiate between the strong acid, the weak acid. You should be able to explain the concept of base, which in some textbooks you see alkaline, and also you should be able to distinguish between the strong base and weak base. And you should also be able to read the P.H scale. There's a P.H scale which I'm going to show you how you're going to read whether a content, a chemical, a substance is an acid or is a base, or is acidic or has a basic property. And this is when you need to learn and be able to have a proper understanding of the concept. So I want to quickly start this class this very time to begin by giving definition of terms. There are some terminologies as we begin to talk about acid, base, salt, ion, pH, and all. You might be confused if you don't have the background knowledge of the definition of terms. So I'm starting with definition of terms. What exactly is acid? Acid are substances that form hydrogen ion when dissolved in water. Any substance at all when dissolved in water actually exude or give out hydrogen ion, positive ion, hydrogen ion. Such a substance is an acid. And base are hydroxides, and when they react or neutralize with water, they give hydrozonium ion, OH negative. So you need to differentiate between the giving off of hydrogen ion and hydroxy ion. Hydrogen ion is a product of acid reacting with water, while hydrozonium ion is the product of base reacting with water. So in acid solution, there are more hydrogen ion than hydroxy ion. So you should note that if water, actually we try to analyze water or hydrolyze water, you are going to get both hydrogen ion and hydroxy ion. So in an acidic solution, you understand that the hydrogen ion content is much more than that of hydroxy ion content. So in an alkaline solution also, there are more hydroxy ion than hydrogen ion. So you need to understand this. In acidic solution, hydrogen ion are more than hydrogen ion. But in alkaline solution, hydroxy ion are more than hydrogen ion. So don't confuse yourself. Now, looking at the properties of acid and base, you may need to have understanding of their properties, because having this understanding will help you to be able to, number one, identify them, two, know their reaction, how do they react, and three, you will also be able to differentiate between acid and base, because there are some of these compound or component or substances that when you look at them by their facial appearance, you may not be able to differentiate between them. But when you look at their properties, you look at what they can do, then you'll be able to distinguish between the acid and base. Now, acid, let's take for instance a lemon or lemon juice or vinegar. This has a sour taste. Acid generally have a sour taste. Acid are harmful to living cells, especially concentrated acid like inorganic acid like hydrochloric acid or tetraoxosulfuric acid or triazonitrifluoric acid. All these acids are inorganic acid. We should understand that acid are both organic and inorganic. Organic acid are acid that are gotten from raw substances, raw materials like vinegar, like lemon. Those are organic in nature. So aqueous solution of all acid contain hydrogen ion. All acid in aqueous form, in aqueous solution, they must have hydrogen ion. Then acid turns blue litmus paper red. So you must be able to understand base will turn red litmus paper blue, but acid turns blue litmus paper red. Then strong acids are corrosive regardless of the nature and the type. In as much as the acid is strong, it must be corrosive. Let's look at base. Base are also called alkaline. So they are having a bitter taste. Remember, acid has a sour taste, while base has a bitter taste. Now, strong acid or strong base rather, which we call alkalis, they are corrosive. An aqueous solution of all bases contain hydroxide ion, just like the aqueous solution of acid contain hydrogen ion. In the same vein, aqueous base also contain hydroxide ion, which they call hydroxide ion, OH minus. Then instead of base turning blue litmus paper red, base actually turn red litmus paper blue. And if you look at base, naturally they have a soapy touch, a very soapy, slippery touch. That is base, and it's one of the properties you can use to distinguish between acid and base. Anything that is looking slippery, soapy is not acid, it is a base. We need to go through this so you understand. Now, there are some things we're going to be talking about. Ion, we talk about hydrogen ion, hydrogen ion. What are these ions? How are they? I mean, how can we differentiate them? How can we identify them? So sometimes substances go through a reaction that break off a hydrogen or even a hydrogen ion. It could be hydrogen or hydrogen ion or oxygen. When these substances are break off, then there's an emanation of charges. These extra ions, they are charged particles, and they are what makes up the acid and base. So acid and base can actually be subdivided into particles. We can see both hydrogen ion and hydrogen ion right there. So looking at it, if you look at water and you allow water to go through hydrolysis, you're going to discover that in water there are two fundamental ions, the hydrogen ion and the hydroxy ion. So because the single hydrogen no longer share that electron, it becomes positively charged. Please remember when we dealt with the concept of periodic table, and we're looking at how charges emerges and how charges react. So in the same vein, any single hydrogen that has no capacity to share electron becomes positively charged, and now we can call it hydrogen ion because it can no longer share its electron. So it then must be positively charged. That's what we call hydrogen ion, H plus. Now when you look at substances and then like elements like oxygen and hydrogen that have an extra electron and become negatively charged, they are now called hydroxide ion. So when a particular ion has a negatively charge, especially oxygen and hydrogen, and that's why I gave you OH minus. You see this in many external examinations. So any substance that has extra hydrogen ion is an acid. So the more hydrogen ion, the more acidic. So if you have 2H2 plus, yes, that means 2 hydrogen ions. So the more acidic that substance will become. So when you have OH minus, that is basic, and that has a basic property. Now looking at the ion further, looking at the acid further, you understand that acid can now be differentiated from base based on certain prerequisite. We can now say, okay, this is an acid, this is a base, based on certain parameter which I've highlighted up there. Now when a substance has extra hydroxide ion, then it is base. So the more hydroxide ion, the more basic. Please note this: the more hydrogen ion, the more acidic; the more hydroxide ion, the more basic. So bases can now be called alkaline. So we can now call bases alkaline based on the fact that it has hydroxy ion as part of its component, OH minus. Now we need to now know to what range, if we are to put acid and base on scale. Let's look at the scale. Let's put them on scale. Let's analyze how we can actually be able to identify acid and base. Now a pH scale has it has a reading, a calibration from 0 to 14. Now when looking at the scale, from 0 to 6 is purely acidic, 7 is neutral, and while from 8 to 14 is actually alkaline. It's basic in nature. So you need to know and understand this concept. If you have acid and base, putting them on a scale, there's a reading, there's a calibration. You need to understand this, and you need to work with this. Now from 0 to 6 is acidic, and from 7 is neutral, and from 8 to 14 is purely alkaline. Now looking at this pH scale, if you look at it, there's an increasing order of acidity, and there's decreasing order of acidity. There's an increasing order of alkalinity, and there's a decreasing order of alkalinity. Let me explain this further. If you look at it from 0 to 6, 6 is the least acidic because it's closer to the neutral level. 7 is neutral. So any substance that actually has a close proximity to 7 on the pH scale, it's actually a weak acid. Please note this. I've seen this in external exam questions. So any substance that has a close proximity with 7, if it is 6, is very least acidic. If it is 8, is the least basic. So you need to understand how it increases. Now it means that acidity increases from 6 to 0, while decreases from 0 to 6. And 7 is neutral, like I said. Then it means that alkalinity actually increases from 14 to 7, while alkalinity decreases from 8 to 14. It increases from 14 to 8 and decreases from 8 to 14. This is how the pH scale works. So if you look at battery acid, it's very, very acidic. In fact, that's why you wouldn't go near to taste or to allow you to touch your body. If you do, you're going to see the harmful effect of this particular substance. So lemon juice is also very acidic. Vinegar is very acidic. In fact, you can find vinegar in adult, when in fish reproduction. It's very, very important that you know this. In fish reproduction, vinegar actually affects the reproduction because of its level of acidity. In fact, in acid rain, if you look at the content of the acid rain contains two important contents: the nitric acid and the sulfuric acid. These are very strong acid, and that is why we need to look at the range so that you know what you're working with. Now coming to the alkalinity, I told you that alkalinity increases from 14 to 8 on the pH scale and decreases from 8 to 14 on the pH scale. And the milk and ammonia, all of them actually has a close proximity with the pH 7, and pH 7 is neutral, so they are less of alkalinity. They have a low alkaline content compared to the other chemical that has a very high acidic or alkaline content. Now let's go further. Like I said, if you look at urine, generally has pH of 6, whereas water has pH of 7. It means that water is neutral, it's neither acidic nor basic. I've seen this question in external exam. So water is neither acidic nor basic. It's a neutral content. That's why we can take in water and the other solvents in chemistry, and generally we refer water to a very neutral substance, that has a neutral pH because it's exhibiting a pH of 7. And this means that urine has 10 times more hydrogen ion than water. So urine has a general pH of 6. So it means urine is acidic, but not a strong acid. Urine is never a strong acid. Please don't make that mistake. It has a pH of 6. So it means that although it's 10 times higher in terms of the ion content than water. So you need to know this. Now, because pH 7 is considered to be neutral, what it means is that as many hydrogen ion as there. Now we need to compare hydrogen ion and hydroxyl ion together, And as we do this, we need to cut out the balance. And the balance actually comes when we are staying on pH of 7. Anything from 7 upward, 8, 9, 10, 11 to 14 is very, very basic. It has a very high basic content. And anything from 0 to 6, it has a very high acidic content. You need to understand it. Now, we must distinguish and differentiate between strong acid and weak acid, because when we talk about acid, and I told you there are two types of acid. We have the organic acid and inorganic acid. However, we have some of them that are very strong and we have some that are very weak. So you need to be able to differentiate between the strong acid and strong base. Now, acid or base, whatever, they dissociate in water. When they dissociate completely, they are strong. When they dissociate partially, they are weak. Can I say that again? Please note this. When acid or base dissociate completely with any solvent, then they come out very strong. They are called strong acid and strong base. But when they dissociate partially, that is, they dissolve partially, then we refer to them as weak acid. Why? Because the part of ion, hydrogen ion, in their content still remain with them. So they dissociate partially. They mean they are weak. But when they dissociate completely, they become very strong. Now, I need to take you through the concept of neutralization, because this will form the basis of your understanding as we begin to demystify further into the properties of acid and base. And there are three parameters we're going to use based on three scientists that helped us to quantify the extent to which we can be able to further distinguish between acid, base, and salt. There are some unique properties and there are some reactions that each of these content exhibits, and we cannot be able to explain explicitly and extensively until we follow these three fundamental principles given by Arrhenius, Brewster-Lowry's theory, and also Lewis' theory. These three theories are what we're going to go into. We're going to go into details, and we're going to use their postulation as basis of our explanation. So, but you need to know what neutralization means. Actually, neutralization reaction is the reaction between acid and base to form salt and water as the only product. Can I say that again? When acid and base react together quantitatively, because anything we are doing in chemistry, we must be quantified. So quantitatively, when we talk about the reaction of certain measures of acid and that of base reacting together, they actually form salt and water as the only product. So in the process of mixing together, chemically combining together, that process is what we call neutralization. Can I give some example? When hydrochloric acid and sodium hydroxide, hydrochloric acid is a strong acid, sodium hydroxide is a strong base. So when these two contents react together chemically, they actually give sodium chloride and they actually give water as the only product. So you have HOH. This HOH here can be rewritten in another format to say H2O, because we are having two molecules of hydrogen reacting with one molecule of oxygen to give water. So if you want to go into further analysis, take tetraoxosulfuric acid and potassium hydroxide together, bombard them under a conducive atmosphere, then you're going to have two fundamental products, which are water and potassium sulfate. So this is complete neutralization reaction. Now you have I've taught about acid, I've talked about base. Now let's do a little review on salt, because we are going to take each of these content, acidic content, basic content, and salt. We're going to analyze them one by one using certain principles and parameters to justify our explanation. So we need to look at salt. How is salt formed? What are types of salt? What are the reactions of salt? These are what we need to quickly look at. Now let me quickly give you the introduction to salt. Now, when hydrogen ion of an acid is replaced by metal or metallic ion, a salt is produced. Can I say that again? When the hydrogen ion, remember, acid produces hydrogen ion. When this ion reacts chemically or is replaced by metallic ion, salt is produced. Now, can I give a chemical equation to back this up? Now, when you look at tetraoxosulfuric acid, H2SO4, reacting with hydroxide, then you have sodium sulfate plus water coming together as a byproduct. So it means that the hydrogen ion from tetraoxosubstituted acid has been replaced by what? By sodium. So sodium is a metallic ion. So when sodium replaces the hydrogen ion, that means something is formed. What is formed is salt. So in this chemical analysis, you have been able to see that hydrogen is displaced, it's knocked off, it's replaced by a higher metallic ion, which is sodium right there. Yes, sodium sulfate actually is the salt formed. Why? That salt is called an ionic compound. Why? Because everything we do in chemistry, there must be justification, there must be a reason. We don't just chemicalize equation without having justification. So the justification here is that particularly hydrogen plus is knocked off and replaced by sodium ion. So this kind of formation, this kind of salt formed is called ionic compound. Now there are methods of making soluble salt. I'm going to teach you methods of making soluble salt. Please look at this I'm about to say. When acid and metal react together, they form salt and hydrogen. So in a very explicit way and a very direct way, if you want to get your salt and hydrogen, what you need to do is just take an acid together, whatever, especially inorganic acid. Take inorganic acid, bombard it with metal, then you are going to get salt and hydrogen. Then number two, when you react acid and base together, you get salt and water. Please take note of this. Acid, metal, what do you get? You have salt and hydrogen. Now come to another method. Acid and base, you have salt and water. That salt actually is as a result of the hydrogen ion and the hydroxy ion from acid and base respectively. Now when you now take acid and carbonate, like sodium carbonate, like potassium carbonate, when you take it together and react with acid, you form salt, water, and carbon dioxide. So these are ways of making salt. You can see that in the three equations, we are able to make our salt. So there are three, in fact, there are more than enough methods, but fundamentally, in chemistry, fundamentally, the three easiest way of getting your salt is number one, react your acid with metal, number two, react your acid with base, and number three, react acid with carbonate together. When you do this, you are going to get your salt. Now there are types of salt. The first one is normal salts, and when we say normal salts, we mean salt that are formed when all the replaceable hydrogen ion in an acid have been completely replaced by metallic ion. That's when we say it becomes a normal salt. In WAEC, in O level and A level chemistry questions, if you notice yearly, these questions on acid, base, and salt must actually emerge. You must see it because it's very important and it forms one of the core parts of chemistry. So this is why you must be able to subscribe to our YouTube channel and watch videos that will guide you and equip you, enough for you to be able to tackle most of these problems. So normal salts are formed when all replaceable hydrogen ion in an acid has been completely replaced by a metallic ion. Now let me give you another example. When you take tetraoxosubstituted acid and zinc oxide, you bombard them together, you realize something. Number one, you will have zinc sulfate as your byproduct, which is the salt. So if you have heard about sodium chloride, the salt you use in cooking your rice, beans, yam, what have you, that is sodium chloride, and that is what we call normal salt. Some call it table salt. This is actually can also be produced from chemistry laboratory. We can synthesize this salt you're using, or the salt you see them using in restaurant or anywhere to prepare meal. This salt can be synthesized simply by bombarding hydrochloric acid and sodium hydroxide together to form sodium chloride and water as a byproduct. Then if you want to obtain your zinc sulfate, bombard tetraoxosubstituted acid and zinc oxide together. Then you're going to get your zinc sulfate and water. Now we also have what we call acidic salts. in some textbooks or online, you see acid salt. It's still the same thing. Don't make me. It means, what it means is this. These are salts that are formed when replaceable hydrogen ion in an acid are partially replaced. They are not completely replaced. They are partially replaced by metal. So we call such kind of salt, we call them acidic salts. Now take for instance, tetrahydrosulfuric of this acid, bombarding it with potassium hydroxide. What do you have? You have potassium sulfate and water. So it means that from here, the hydrogen ion from tetrahydrosulfuric of this acid is not completely replaced. It's not completely replaced. So we have two molecules of hydrogen ion. Only one was replaced. So it's not completely replaced. So we call it partial replacement. And such chemical combination results into what we call acidic salt. Now, can I go further? Let me tell you about the basic salt. Please note normal salt, basic salt, acidic salt. Let me analyze basic salt for you. Now, we've been talking about normal and acidic. Now, let's turn to basic. Do you know that basic salt contain hydroxide ion? This hydroxide ion, they are formed when there is insufficient supply of acid for complete neutralization of the base. Now, I told you earlier on, you know, we are taking this systematically, and it is very important for you to have the understanding, because if you are not following, you may not be able to have a comprehensive understanding. Now, we started by neutralization. I told you that neutralization simply is the reaction between acid and base quantitatively in a certain quantity in order to form water and salt as the only product. Now, we are now trying to analyze further what kind of salts can be formed. How can all these salts be formed? What are the situations that makes or that warrant these salts to be formed? These are what we are trying to trace. So basic salt contain the hydroxide ion, and these are formed when there's insufficient supply of acid for complete neutralization of the. In other words, if you are taking 10 mils of acid and you want to achieve a complete neutralization, you need to take the exact 10 mil of base. Reacting them together will give you your expected result, your desired result. If there is a less quantity, if there is a kind of deficiency or insufficiency in the amount, the quantity of the acid or base you are using for chemical synthesis, you will not be able to get your result. However, if you get any result, if you form, if any salt is formed, it means such salt will be basic. Why? The reason is because you have more hydroxy ion than hydrogen ion. It's very simple. It's very, very simple. Let's go further. Now, let me give you the types of salts, some common salt we have, and their uses. Please, you need to understand, or you must have been seeing ammonium chloride, ammonium nitrate, calcium chloride, iron sulfate, magnesium sulfate. You wonder, where are they coming from and what are their uses? You know, in gunpowder, what they use is potassium nitrate, because potassium nitrate has capacity for explosion, and then it helps ignition. It helps ignition. So potassium nitrate will be used in gunpowder. When you look at photography, I hope you know that in photography we have what we call silver bromide. This silver bromide is also engaged because it's a salt which must actually be used, especially when you are preparing a film. When you are trying to clean the film and want to picture and bring out your image, silver bromide is very important. That's what they use. You don't use water or any other salt. That's what they use to get your result. Now, sodium chloride, in making, you know, all kind of soup, anything you want to eat, anything consumable, eatable, sodium chloride is fine. That's the normal salt. That's a basic. However, don't use sodium stearate, because if you use sodium stearate, you are going to have a soapy substance coming out of your food, because they use sodium stearate mainly for making of soap, all kind of detergents, all kind, and even hand soap. What they use is sodium stearate. And then in iron tablets, you see iron sulfate being engaged. Calcium chloride is used as drying agent. Ammonium nitrate is used in fertilizer, you know, NKP. Have you heard about that? NKP, all kind of fertilizers. Ammonium nitrate actually is engaged in most known fertilizers across the world. Fertilizers used in enhancing the growth of all kind of plants. So ammonium nitrate is that salt that is important, that must be part of the content of any fertilizer if at all is going to enhance growth of any plant. Let's take a few questions from our exam guide as we have come to an end of the first module of this particular topic, acid, base, and salt. You need to watch our subsequent video because I'm going to give more detail into this concept in our subsequent video. However, let's quickly take a look at a few questions from our exam guide. All right, now question number 1, consider the diagram you are seeing on the screen. We have a setup. This is what we call quantitative analysis. I'm going to take you through what quantitative analysis means. And in quantitative analysis, we try to analyze the content of acid reacting against base, and we want to look at the kind of reaction that takes place. Now look at the setup. Consider the setup. We have dilute acid. I told you dilute acid could be tetraoxophosic acid, hydrochloric acid, or triazonitric acid based on choice. Now they use dilute acid, which could be any acid. Now looking at sodium hydroxide, which is what? A strong base. Look at the setup now. The setup is used for preparation of salt by one. Option one says a double decomposition, B, crystallization, C, neutralization, D, direct combination. If you look at the setup, they are neutralizing acid and base together. This is a very good question that actually attestates to what we have learned so far in the course of the teaching. So this is reaction between acid and base. So it's not crystallization, it's not decomposition, it's not combination. What we have here is neutralization. So neutralization is very accurate. Now look at the next question right here. The question says an acidic salt has a double anion in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ion in its aqueous solution. Remember, acidic. I told you that what comes out when you react acid with water or with anything is the hydrogen ion, which is part of the component of an acid. So here C is very accurate, hydrogen ion in its aqueous solution. Let's look at the next question before we end up this teaching. Now look at this. Salt that contain water of crystallization are said to be A, anhydrous, B, deliquescent, C, effervescent. In fact, I don't want to go further because I'm already seeing the answer. But you know why? Let me explain the concept. Salt that contain water of crystallization are said to be effervescent because of the fact that this water are gotten from the atmosphere. So we call it effervescent because if you look at a reaction of acid can sometimes be exothermic and sometimes can be endothermic. So, but when a salt contains water of crystallization, salt is referred to as effervescent salt. So here we come to an end of this module. I want to encourage you to subscribe to our YouTube channel and watch our subsequent video. And I'm going to, in the next video, I'm going to open your eye further to all that you must know. You know, I told you of 3 important scientists that talked about acid, base, and salt. I told you of Arrhenius, I told you of Bristolari theory, and I told you of Lewis theory. Let's go further as we do justice to this theory. So meet me in the next video to have a comprehensive knowledge of the concept of acid, base, and salt. Till then, take care. I will see you in the next video.